the thinking is that any technology that is out there and really wants to scale needs to be able to work with the grid as it is, not as we want it to be. One of the things about this all-electric drivetrain that we have for carbon upcycling's process is that you can capture and sequester this carbon into solid products, essentially whenever you want, right? Like, so if you're a petrochemical facility, if you're a mining company looking to sequester carbon, you don't have to sequester that carbon, at 4 p.m. in the afternoon when, you have to pay huge amounts for that electricity. Instead, you can wait till 7 p.m. at night or 9 p.m. in the evening and use very cheap electricity. And in regions like Belgium and France, where sometimes you get negative electricity prices, the thought is that a technology like ours can actually create a direct arbitrage between these, relatively abundant electrons at off-peak hours directly to CO2 being sequestered into products that are then being sold to create further value add benefit.
Well, welcome back, everybody, to the Decarb Connect podcast. And this week, I am very, very pleased to be talking with Apoorv Sinha, who is the CEO of Carbon Upcycling. So not only pleased to be talking with him because it's a type of technology that I'm somewhat obsessed by, but also because actually in Decarb Connect's own history, the team at Carbon Upcycling were probably one of the very first market calls we had when we were sort of trying to work out what was going on and what we could do in the industrial decarb space. So 4 and a bit years on, really good to be connecting with you, Apoorv, and to be learning really about this amazing journey that you and your team have been on. So welcome to our podcast.
Thank you so much for having me, Alex.
So I am going to kick off with my classic, is Alex a genius or just a bit of a lazy podcaster question? Who knows? We'll go with that anyway, which is, can you tell us a little bit about how you've arrived at this point in time? So, carbon upcycling is now full on scale up, so much going on, but clearly there are so many triggers and paths that bring you into a journey like this. What's it been like for you? What brought you here?
Yeah, it's a great place to start, Alex. And as we're finishing up our 10th year of operation, we've been reflecting on this quite a bit. And personally, I have a chemical engineering background. I studied down in the States at Georgia Tech, and had my degree in chemical engineering there. But before that, was always kind of absorbed in the energy sector generally through my dad's profession. He worked in the conventional energy sector for many years. And so I grew up in India working, with my dad working in a national oil company, and then also in the Middle East for many years, where I did most of my childhood. And so having seen all of what the conventional energy system looks like really informed me as to how to think about this broader energy transition question that we're now facing at a global level. And yeah, over the last 10 years, as you mentioned, carbon upcycling has really grown quite steadily. For the first 5 years of the company's existence, we were primarily a research and development organization. We were working a lot with universities and academic partners, trying to figure out, what could be an interesting product that could maybe fit a product market fit and solve a real problem. And over the last 4 years, we've identified that cement and building materials is a great beachhead market. But as we'll talk about, I'm sure through the conversation, there's a much bigger story to what we're doing with our carbon to value, carbon techs solution than just what we can do for cement.
And what was the route that took you, because you now live in Canada, right? So how did you,
That's right.
we've heard India, Middle East, uni in USA, what brought you up to Canada?
Yeah, so I graduated from my undergrad in 2010. So this was right at the back end of that mortgage crisis, the financial crisis back then. And being on a student visa in the States at the time, it was extremely difficult to find a job in the energy or sustainability sectors at all within the US. So at the time, I made the decision with some counsel slash poking from my very insistent parents that Canada seems like a good place to go. So 12 years later, I was, I'm still here.
Oh, well done to the parents. Always good to have a push from the right direction. Well, look, let's look first of all, let's just give a bit of context for the conversation we're going to have. What was going to be talking about carbon upcycling's technology, the business model, and all kinds of things like that. Before we do, give us a feel for those people listening who may obviously understand what carbon dioxide recycling or reuse or value to additional use. They understand the words, but what's the shape of that space, and then where do you really sit in it?
Yeah, Alex, it's a very broad question, and maybe I'll just start by saying that overall, carbon capture, utilization, and storage has been becoming more and more of a hot topic. Essentially, what it refers to is the overall problem that we have of 36 gigatons of emissions that are produced by human activity every year, and trying to find some place to put that pollution. Now, the baseline case for this has been to store it underground, and I can't speak too much in the short conversation kind of that we'll be having today about kind of the broader space of carbon to value or carbon tech that we're going into. But what I can say is that ultimately what carbon upcycling is focused on is a scalable way that can go to gigaton level removal of carbon dioxide from industrial sources to make valuable products. And this entire story of kind of changing CO2 from being a pollutant that is, an inhibitant or some kind of a hindrance to human progress, to actually making that a molecule or an ingredient that can actually help us make more valuable products, more sustainable and durable products. That's something that we just genuinely believe in. And luckily, over the last 4 or 5 years, we've been making some real good progress in demonstrating that this is possible with all the R&D and more recently scale-up work that we've been doing.
Yeah, I feel like particularly the last 18 months, 2 years, there seems to have just been a nice steady growth in the number of stories and projects of different kinds in this particular, the CCU space. So it's obviously a lot of different types of technologies with a lot of different use cases coming to fruition. So obviously we're on an audio podcast, so with all the challenges that might bring, can you try and help the listeners and I visualize, like, what does your tech look like if we were on a site? What would we see? What kind of space, what kind of impact on a site does it have? And for anyone wondering why I lead with this question, it's because honestly, most of the time when I'm talking to some of our industrial clients and members about the podcast, the question they often have is, but can you just get them to tell us what it's going to be like on our site? What is it, what space it takes? So as best you can, give us a visual.
Absolutely. Yeah. And Alex, we've seen this to be a very powerful tool as well. Like as we get new people to be informed about our story. And first and foremost, what I would say is if ever any of the listeners are out in Calgary, we'd be happy to host them so they can see the real thing. And of course, over the next 2.5 years, we'll have projects in Belgium, in the UK. We'll have projects in Eastern Canada and potentially in the US as well. And so there'll be many different places where you can see this stuff firsthand. But just to try to do what I can on an audio format, what I would say is that ultimately, if you've ever been to a cement plant, the equipment that we're talking about would not look very different from some of the front end equipment that you would see at a cement plant, and frankly, even in a mining facility. And so, for many of the listeners that may not come from an industrial background, essentially what that means is, there are three major steps to every carbon upcycling module. There's the first step, which is the pre-crushing and the grinding step. So this is not very dissimilar to seeing massive, mills or grinding stations that you might see at certain cement plants, even steel plants and mining plants. And essentially what you're trying to do with this is you're trying to take different types of equipment that can really take big rocks and make them into very small powders. And this is important. One of the first things that we realized is that all of the chemistry we're trying to drive of, essentially sequestering carbon emissions, which are primarily gaseous, into solid products, a lot of this depends on how you prep the solid so that it's ready to take on that gas. And so over the last 2 years, we've done a huge amount of work at looking at different types of milling equipment to see which ones are best for milling X, Y, or Z feedstock. And so you'll definitely see that on the front end of almost every carbon upcycling process. And then the second piece, which is really where our key innovation and scale up has come in, is the reactor. And so what we mean by the reactor is essentially, it doesn't look very kind of exciting from the outside because it's essentially, a shell inside of which you've got this churning powder in the presence of gas and humidity and a few other things that we try to tweak. And it's not very different from what you might see in a chemical facility. where, generally when we think of chemistry, like going back to middle school and high school, we're talking about liquid chemistry in a beaker. You've got like one liquid and of one color, and then you're usually using a test tube to drip something in. Our reactor is a little bit different than that because we're dealing with solid gas chemistry. So imagine, something like a material transfer unit, like a silo, or a screw auger that you might see at a grain handling site. And we've essentially tailored equipment that sort of looks like this to the kind of unsophisticated eye, and essentially got it to a place where you can actually promote chemistry instead of just moving material. And so you'll see both of those pieces. And lastly, you'll see a lot of ducting. You'll see a lot of process handling, kind of auxiliary equipment. You'll see sensors of all types. You'll see big fans, and loud motors and drives. You'll all definitely see a control cabinet. And yeah, I think overall, you wouldn't be able to tell this equipment apart from a cement production or a mining piece of equipment, which is really an advantage because ultimately what we look at is what these sectors need to do to decarbonize, and at some stage of this adoption cycle, they have to have their operators feel very comfortable with the equipment that's being given to them. So we have deliberately chosen unit operations and pieces of equipment that these guys are very familiar with so that they don't have sticker shock. Like, you do not want, a small modular reactor to go out to someone who's run, a cement plant, right? Like, you want something that they've seen and touched and felt. And yes, of course, it's different because what you're trying to do with it is different. But I think, the fact that we've been able to stick to something that looks relatively standard has been one of the key reasons that we've been able to scale up as aggressively as we have.
It's a really interesting kind of a thought, actually, as I'm thinking about other disruptive and scale tech that's scaling up. It is that level of comfort that people have with it that obviously improves, I guess, engagement of demo, then pilot, and then scale up teams around the technology itself. That's, yeah, interesting thought. So one of the other things that we often get asked by clients is then, for those that are further along the journey of looking at, okay, I can capture my CO2, I can either send it somewhere to bury it or do something with it. The next question, or rather the next issue that many of them come across, is all of a sudden it's like, oh, what's my concentration? Why does that matter? What are the particulates in my stream? Why does that matter?
Mhm.
So where do you sit in terms of the types of streams that you're able to cope with? And therefore, what does that mean about, I mean, you've already mentioned, obviously, being in the cement and building materials sectors where you started, but what does that mean about where you're looking next as well?
Yeah, it's a really good question, Alex. And one of the nuances that, I was very excited to dive into as I was prepping for our chat today, because I think you're right. Like, when you're a layperson looking at carbon capture, I mean, you're probably just envisioning some kind of a filter on a big stack that you see emitting CO2 into the air. Now, one fun fact for maybe your non kind of technical listeners is the fact that the majority of the emissions that we see from an industrial stack as we drive by are not CO2, right? Most of that emissions stack is actually water, it's nitrogen, it's oxygen. We're currently with our pilot units co-located with a natural gas plant, a combined cycle natural gas power plant. And in that case, only 5% of what comes out of that stack is CO2. On many days, it's less than 4%. And so essentially, when you talk about carbon capture, that's, how do we take that 3, 4, 5, sometimes 10, 15, 20% CO2 up to a high enough concentration, a pure enough stream of CO2, where you've separated it out from, water or oxygen or nitrogen. And to your point, I think one of the key milestones that carbon upcycling hit about 3 years ago was we proved with our mineralization technology, which is the solid gas chemistry I was talking about a minute ago. We've shown that we can take that 4% CO2 right from the stack without needing to do carbon capture on the front end. And this is a pretty important piece because, again, when you talk about industrial pieces of equipment, and you were talking about helping your listeners visualize what we're doing, I think one thing maybe that I missed on there was to talk about the scale of what we've got, right? So each of these pieces of equipment, these are not lab scale pieces of equipment anymore. I mean, these are pieces that would probably fit in a big conference hall somewhere, right? Or the largest piece of equipment that we have, which is the reactor that we commissioned 2 years ago, that unit would probably not fit behind a 40-foot trailer, right? Like it's probably 60 feet by 100 feet and the overall footprint, if you take everything else into account, is close to 500 square feet, or 50 square meters for the non-American listeners. And so I guess because this stuff is so large, when you have a step like, pre-carbon capture that you need to do, whether it's a chemical system like an amine capture process or a membrane-based capture process, not only does it add cost, it also adds space constraints. And, obviously our technology on the utilization side, of converting this CO2 into a solid product that the cement and the building material sector can use, that does improve if we have carbon capture on the front end. But the unique benefit of what we've been able to show so far is that we can use this CO2 as is without needing to invest in what is still relatively expensive carbon capture, and essentially offer a one pot solution, or a single step solution to both capture the CO2 and to make it into a useful solid product. And that has really been, to us, probably the most important lever in unlocking short-term scale opportunities, because when you're talking about these commodities that are so inexpensive, I mean, a dinner in London costs more than a metric ton of cement, right? Like, I mean, you cannot compete in these things if you've got expensive um, modules that you need to add to your process. And when we've been able to demonstrate to some of our steel partners, cement partners, mining partners that we can take that CO2 as they produce it, run it through our system, through those three steps that I was telling you about, essentially they get very excited because they say, okay, well, this is very cheap. This is a one solution kind of problem, and not something where they need to take on a compounding technology risk by trying maybe two or three different technologies all in series.
Mm. And of course, anytime you don't have to add another function, you're also not adding more energy consumption. And that, depending where you are in the world, I mean, it matters everywhere. But yeah, if you're talking to UK manufacturers and industrialists about that, they will always talk about how much more expensive power is it. So if there's an opportunity not to have yet another additional process, a part of this bigger process that's sucking power, then that of course is another bonus. So that,
That
oh,
was
sorry, go on.
just on that point, Alex. I just wanted to say that the one thing I remember from my capstone project, incidentally, my professor back at Georgia Tech was also British, and the one thing he said, which has stuck with me, is, if there's nothing else I remember as a good chemical engineer, the one thing I should remember is fewer moving parts is a better process. And so it just kind of nails down exactly what you're saying there, I think.
Yeah, absolutely. So we've talked a little then about the concentration of CO2 that you and your team can process. Are there any, I guess I'm trying to think of a good example, but I know a couple of our clients have talked to me about how they've been unable to use certain CCS applications because of the content of that flue stream as well, as in, I guess, particulates or toxic.
Particulate
Yeah.
matter, or yes, yeah, absolutely. And that's again one of those things where, because we're dealing with waste of two different sorts to make our final product, we tend to be a lot more forgiving about the quality of the feedstock. So just to give you an idea, so I've talked a little bit about kind of the solids that we treat with the CO2. I think it's maybe a good point to in the conversation to talk about what those solids are, and primarily they're industrial byproducts. And so we're taking slags as an example from the steel industry, or clays that are left behind by mining for other important minerals. In some cases, they could be bentonite and zeolites that are used for high-end applications, but they leave behind this clay overburden, which we can mechanochemically activate to serve as a both a sponge or a sink for CO2, but then also to make cementitious products. We've also done this for mining, and more recently, we've been doing quite a bit of work on ashes, not just from legacy coal power plants, but incinerator ashes from waste to energy plants. But in each of these cases, as you can imagine, these are not clean materials. When you make steel, the slag that you make, for every ton of steel, you're probably making 150 kilos of slag. That slag is pretty not clean, right? The mine tailings that you have from nickel mines or copper mines or sometimes bentonite mines and things like that, again, very impure materials. And so when you're dealing with a CO2 stream, like from, let's say, a cement plant that has alternative fuels. So they're burning not just coal or petroleum coke or natural gas in some cases, but they're also burning refuse from the local market, to lower their emissions and be a good stakeholder in the local community. When they do that, all of that garbage also produces, trace amounts of chlorine, or it might produce NOx, and it might produce particulate matter, as you mentioned. And so what we have been able to show so far is that because the solid product that is absorbing the CO2 is also relatively dirty, for the most part, and I don't want to make a blanket statement and say you can have whatever you want in the flue gas and it's going to work. That's never the case. But, there are more kind of tolerable limits of NOx or SOx or chlorine amounts that you can accommodate when you're dealing with other solid products, which are relatively impure as well. And I think that's been one of the other key findings as we've really scaled up. When you're doing this benchtop work, you don't really have the ability to be able to kind of see the impact of those type of contamination parameters on the final product. But as we've done, a few hundred tons and now a few thousand tons of production, it's become more and more clear that we have a wider band in which we can operate. And I would say for the most part, again, cement is generally a performance-driven product. And so if you can get to the final performance without sacrificing, something that would make the customer feel unhappy, for the most part, it can be relatively forgiving.
Okay, well, let me just ask, it's a slight swerve on this question, but one of the things that I'm interested in about your solution, the way you also, in our prep call, the way you were talking about it, is its link into something that we've been hearing more and more about, which is industrial symbiosis, or certainly circularity, perhaps a more common word for it that is, they've been used quite a lot. And I just have this sense, it's not very scientific, but it really feels like in the last 18 months or so, more and more the conversations we have with clients they're sort of looking for that sort of circular symbiotic approach, not just looking for a one-off solution, a one-off. I'm wondering why, what do you think is changing? Because you've been going for 10 years, you've obviously seen real changes in how industrials perceive the challenge of CO2 and perceive their place in it, the opportunity around it. What do you think is driving that kind of shift?
Yeah, it's a really good question. I will say, maybe I'll answer the question in two different ways here, Alex, but just to try to be concise if I can. But historically, if you look at kind of back into the late 1600s when the Industrial Revolution started and things like that, I think one of the things you saw was a divergence where, the way we made textiles, the way steel was made, energy was made, switching from wood to coal, all of these things were using the same principles, but in divergent paths. And you saw all of these different kind of industrial processes take their own lanes. And I would argue that leading all the way up to, the early 2000s, when the clean tech kind of first wave of venture capital and private investment really began to take off in the mid aughts or so, this was still the case where there was hyper specialization all the way through, and steel cared about steel, cement cared about cement, and EVs and were not really a thing that much back then, but combustion vehicles and generally transportation kind of looked at it this in its own way as well. But I think over the last 10 to 15 years, like since the clean tech 2.0 kind of wave has started since 2014 or so, there has been a difference where I think what's become very evident is that in that 250 years of industrial revolution or post-industrial revolution work that has happened, all of these, wins in incremental marginal improvements in process efficiency, new industrial design, et cetera, has been absolutely milked to the final drop, right? To the final drop. And so there hasn't really been as much of disruption if you really think about, the way we made steel, cement, fertilizer, even energy, really. Solar panels, like the fundamental chemistry behind solar panels and wind, has been around for over 80 years. It just took us that long to scale it up, and the right incentives and the policy dynamics to come together. And so I think that recognition that the only way to get the next level of improvement that we need, coupled with the fact that there's now this urgency around climate and circularity that wasn't there before, has now, I think, forced the strategics to start looking outside of just the boundaries of their own sectors. And I think what we've also seen is that this really affords startups like ourselves some really unique power, because we do have a mandate almost just to survive, to talk to different companies in different sectors. And so, a lot of times, if you look at kind of the large organizations and the way the inertia has kind of set in, many of these organizations do not necessarily know organizationally how yet to collaborate with other sectors that don't necessarily affect their bottom line in a direct way. And so I think for startups in this day and age, I think there is a responsibility, frankly, to serve as these bridge makers, where we help a cement company engage with a steel company or a mining company or an energy production company. And to an extent, I don't want to sound as if flippant about how much of that is already happening. I mean, there's no doubt that there are examples of companies that are already doing that. But I think if you take a new technology kind of angle where you help bridge that divide by looking not just at the bigger level picture, but also some of the technical issues around heterogeneity of feedstock, contamination issues, things along the lines of what you've just been asking me about. I think that there's a massive opportunity for startups to make a disproportionate impact. And that, frankly, makes me feel very excited about the type of potential, not just us, but other companies like us in this space can have over the next 10 to 15 years.
Well, I know later in our conversation, we're going to talk a little about your sense of the systemic impact that you and your tech and your team can have. But I think that's a really interesting lens on industrial symbiosis and the opportunities around it, like the role that you could play almost as connective tissue between different parts of the industrial landscape is interesting to see how that will continue to emerge. Before we dive into the kind of systemic thought processes, that kind of back up carbon upcycling, let me ask you a kind of a big question, which I guarantee any industrial listening to this who isn't yet engaged around CCU is already thinking, which is, but what are the economics of this? And I think sometimes, obviously there's that question around all emerging new or advancing tech, but I think it's particularly true for CCU because so much news and so much discussion has been about the kind of big CCS, the big storage plays, that big kind of physical infrastructure, that perhaps that's led people to think of CCU as this kind of, it's that bit, it's difficult, it's whatever. So anyway, let's not dwell on what people's assumptions are, but what can you tell us about the economics of your solution? What is it? What does that look like for people?
Absolutely. And I would say this is definitely the elephant in the room as we look at the energy transition, right? I mean, even the most progressive end of people investing in this space, like Bill Gates and the Breakthrough Group, has talked about the green premium and how that has to come down. And, Alex, what I will say is ultimately what carbon upcycling has done very, I think, well over the last 3 or 4 years, if I wasn't to sound self-promoting, but we've spent a lot of time really thinking about exactly that. And instead of competing with the price of the commodities we're trying to produce. So, the price of this cement kind of commodity in North America, in the West, and even in parts of East Asia has been increasing. But that does not mean that the cost of goods sold or the cost of making cement has been increasing, right? And so, of course, there are some jurisdictions that have carbon pricing where this can actually help create a bit more of an incentive to change. But ultimately, for us, what we've been able to demonstrate is because our process is all electric and does not require heat, because our process can run basically when you need it to. You don't have to run it for the 6 hours or 4 hours of the day when peak demand of electricity means the prices have shot up. You can run it for the other 16 or 17 hours of the day. These type of advantages, and the fact that we deal, like I said earlier, with two waste streams. We're talking about CO2 without capture, which is very cheap. You just have to plumb it in and hose it down your system. And then you deal with byproducts like slags and mine tailings, et cetera, that we're talking about. And so in each of these cases, we've gone with very, very cheap, highly kind of available, large volume materials. And that has allowed us to be very competitive. So with the 2 commercial demonstration units that are already operating and providing commercial volumes of cementitious material into the Canadian market, we've already proven that we're considerably cheaper than the local price of cement. which is goal number one that we had about 3 years ago, was to say that can we be cheaper so that someone can actually make money using our process? And we've already shown we can do that. And every time that our local partner Burnco uses this material in the space, they make money, we make money, which is already better than we can say for many other technologies in the space. Now, what we're trying to drive towards as we scale up our technology and get integrated into cement plants is that we want them to make as much money or ideally more money by using our technology than they would by making cement the conventional way. And that is a much, much steeper hill to climb. It'll take us 3 to 4 years before we can get to the right scale to do that. But again, the playbook is there. If you look at the big success of what we've seen, not just with renewable adoption in the last 10 or 15 years with solar and wind, but also with what we're now seeing with electric vehicles. There was even just 5 years ago, there was this whole notion that just with battery costs and the infrastructure of building new EVs, you can't get any cheaper than ICE. And now, you're seeing all these tariffs come up because they're so cheap to make in so many different places that people are trying to guard their own industry. And so I'm extremely bullish that technologies like ours that are modular and fundamentally just at a first principles level, have all these benefits where you're not dealing with fossil fuels that create NOx emissions or have combustion gases that you have to clean up. You have to do any of that. You're dealing with all electric streams, meaning you have electrons, which are probably the most mobile thing in a country, and the fact that you're dealing with cheap feedstock, both gas and solid. I think these are all things that give us a high amount of confidence that will ultimately bridge that gap and be as cheap, if not cheaper, than the current way of making cement.
Well, I think another time we will dig into perhaps more of that market-based stuff, because as you expand and deliver more projects, as you're saying, in Belgium, UK, and lots of different territories, I think it'd be good to revisit that, because it really is, understandably, at the very least, the first, if not second question, that we hear from
Absolutely.
clients.
Well, and one other thing on that too, Alex, is that, every region is so different. Like you mentioned, the different projects that we're looking at doing right now, and most of them are in Western Europe and North America at the moment. But if you look at, for example, Thailand, Indonesia, India, parts of Eastern Europe, the price of cement in those markets is practically the cost of goods sold or the cost of making cement in most of these Western markets. And so if you really do want a technology that's going to be scalable across the world, you need to be able to tackle that price question, and you need to be able to do that, in our view, agnostic of what the carbon policy in that jurisdiction may entail, right? Because of course, there's no doubt that all of that helps massively, and the adoption of these new technologies will probably be faster in areas that have progressive carbon policy. But ultimately, at least for the next few years, we think the rate of adoption is going to be higher for technologies that have a credible path to being cost competitive with current technologies, and also helping with additional benefits, such as making a better product, helping with kind of social aspects of operating in these markets, and of course, ultimately, climate resilience. Because whenever we talk about building materials and infrastructure, one of the key things we keep seeing is, there are more and more 1 in 100 year events. They're happening in much higher frequency than we would expect this early in the century. And so, when we look at the performance of our materials, one of the things we're very focused on improving over time is how do we not just make a cement, blended cement that is lower carbon footprint at genesis, but also in its life is actually helping be more durable and adaptable and climate resilient. And to us, that's going to be some of the work that will keep us quite busy between now and 2030.
I just want to take this opportunity to thank our production partner and sponsor, Jano Media, for their support in delivering the Decarb Connect podcast. Over the last few years, they've helped us to facilitate great conversations that connect us with our audience, and their skills and expertise mean that we get to concentrate exclusively on generating the content, the conversations that engage, inform, and inspire. When we were talking in the prep call, I knew a fair bit about the company, at least I thought I did, but it was interesting to hear you talk about these other impacts, that the way you work and the way you connect clients or organizations within a region, that there are wider opportunities that your kind of business model, the way you're set up, can offer. So I think it would be great if you could just kind of go talk about this a little bit. Like when you think about carbon upcycling and a systemic impact that you can have, why is that? What is it that you're doing that means that you can have that impact versus just being, oh, we're that piece of plant equipment that you just, connect and when we leave you alone? You're obviously way more than that. How has that come to be? And yeah, what are those wider impacts that you're able to have?
Our mission, Alex, is to be the most impactful carbon tech company of this decade. And when we see carbon tech, we mean carbon to value. So we want to be the most impactful carbon to value company between now and 2030 and between now and 2035. And the thinking behind that is, if we really want to measure that, like as an engineer, I need to have a KPI to attribute to that mission. And really what we mean is we want to abate and sequester or enable the abatement and sequestration of more CO2 tons than anybody else who's doing carbon to value. And the only way we can do that rationally as a 40-person organization is by building partnerships and working with much larger partners that are also interested in doing this in a credible and scalable way. And so I think in a sense, when you dial everything down to its simplest kind of gist, it's pretty evident that all of these millions and billions of tons of emission reductions that we have to do, they're gonna come at industrial sites. They're gonna come at power generation facilities, as cement plants, as steel plants, mining facilities, et cetera. And so, our view is that our technology can ultimately help these companies unlock more value for their shareholders, for their stakeholders generally, in a way that maybe they haven't thought about before because they haven't really had the urgency or kind of the incentives to do that. And so, even once you recognize that, that's step number one is, you have to recognize that you have a challenge or an opportunity. But the second thing is to actually execute it. And since you're British, like I'll make a test match cricket joke. Like this is not a baseball game. This is a 5-day cricket game, right? Like where it just never ends. And so when we see ourselves as kind of being really good partners for these companies that have been around for 100, 150, 200 years, the only way that we can be those credible partners is by playing the long game and really being partners with them, not just in ideating and providing a solution, but actually implementing the solution. And so ultimately, what that's really meant for us is exactly what you said, which is, being, as you mentioned it really eloquently, like the connective tissue between, potentially industries that don't really have, much of a reason to talk to each other. And we've done a lot of work in harnessing these relationships. And many of the industrial partners, some of which are investors in carbon upcycling now, we've been talking to for 5, 6 years, like more than half the company's life, well before we started getting our commercial demonstration units going. Burnco, as an example, which is our partner in the Canadian market, they've been our partners in testing this material for over 7 years. Companies like Cemex, CRH, and others, we've been working with for many, many years. And to us, that is absolutely necessary if we're going to have the staying power to be able to affect the change that we want over the course of the next 10 years.
So just briefly, just to add into that picture, a couple of the things that you and I had talked about as well on the prep call were to do with onshoring and other grid balancing benefits that you bring. Can you just draw in those strands, just to sort of complete that picture?
Absolutely. And again, this talks a little bit to the challenge that we have at hand with the energy transition, right? Like if you look at the massive influx of capital and frankly equipment that's going into artificial intelligence build up, and before that we had the crypto build out over the last few years. All of these are very, very energy intensive operations. And so if you look at all of that, if you look at all the urbanization that we're seeing and the new development of infrastructure, even in developed countries, there's a huge amount of work, all of which needs energy. And what we're finding is that when we look at many of these avenues where we want to create sustainable aviation fuels, or we want to make long duration energy storage options come together, like much of it is around how do we balance the fact that for 6 hours out of every 24, give or take, we absolutely use all of our energy. And that number might go up now with the extreme heat that we're seeing in the summers all across the world. And so the thinking is that any technology that is out there and really wants to scale needs to be able to work with the grid as it is, not as we want it to be. And essentially what we mean by that is, we all want green electrons, but ultimately for every new, marginal electron that goes into the grid that is green, there's going to be a huge amount of competition for that. And especially during these peak hours. And so, one of the things about this all electric drivetrain that we have for carbon upcycling's process is that you can capture and sequester this carbon into solid products essentially whenever you want, right? Like, so if you're a petrochemical facility, if you're a mining company looking to sequester carbon, you don't have to sequester that carbon, at 4 p.m. in the afternoon when, you have to pay huge amounts for that electricity. Instead, you can wait till 7 p.m. at night or 9 p.m. in the evening and use very cheap electricity. And in regions like Belgium and France, where sometimes you get negative electricity prices, the thought is that a technology like ours can actually create a direct arbitrage between these, relatively abundant electrons at off-peak hours directly to CO2 being sequestered into products that are then being sold to create further value add benefit. And so fundamentally, we just think that has to be a key criteria for any technologies that are meaningfully scaled over the next 10 to 15 years, because otherwise we simply will exacerbate this problem of not having enough green power and maybe even increase emissions instead of reducing them.
Okay, well, let me ask you a slightly different question then. We've talked obviously about cement. You've mentioned you work with other industries as well, but let's just keep with the cement value chain for this. How does decarbonisation of cement affect what happens further down the value chain, and how far down that market, that value chain have you gotten in terms of building buy-in or securing that future for the product that you're co-creating? What's that look like for you?
It honestly is probably the most exciting time for how that supply chain is beginning to kind of crank into gear a little bit, and not just from our perspective as a relatively new 10-year-old startup, but from what we hear from the incumbents. Many people have told us that this is probably the most exciting time in their careers, where they're starting to see infrastructure providers, contractors, builders, architects, civil engineers, city engineers, Department of Transportations, all get really excited about how do we get low carbon materials into our projects. And this is primarily happening because I think there's a recognition that with 8% of global emissions coming from cement production, there's a massive amount of I guess just value that can be captured by the upcycling of these processes and using lower carbon materials. But then the second thing is, I think people are seeing that this is one of those virtuous cycles where if you get a low carbon material in, not only does it help on the front end, it also helps with other downstream benefits where, as an example, electricity becomes more available for other sources. You have waste management issues at steel plants or mining plants or decommissioned coal power plants that can also be mitigated as you upcycle these materials and use them to make infrastructure. And these type of upcycling approaches have been used in the past. I think what we're really doing is just building on that overall track record where, a lot of slags, as an example, have been used as aggregates, just gravel in road base. Now, the thing is, it's a relatively unsophisticated application. It does not have a huge amount of value add. It's more of, you're just kind of dumping it under the ground to create a solid base for roads and other infrastructure. But if you can upcycle that material to make a value added product, which has, let's say, an embodied carbon footprint of 50 kilograms per ton instead of 900 kilograms per ton, if you can replace cement 1-to-1, all of a sudden, not only are you still following on that upcycling trend, but you're also creating this knock-on benefit where you're creating more climate resilient, lower carbon footprint infrastructure. And so I think overall, there is a bit of momentum building on this. Just about a month ago, Alex, the White House in the US hosted a concrete innovation summit. Of all the places in an election year for them to do that, tells you that this is a high profile discussion topic. And now there are regional convenings happening. And we're seeing similar efforts happen in Canada and definitely in the EU as well. And yeah, we're very confident that this will lead to some accelerated change compared to what we've seen in the past.
So, but out of interest, when you think about that extended value chain to market for cement, concrete, and onwards, so how far down that would your team, let's say, engage with people? Is there a point at which you're like, yeah, this is diminishing returns, we don't need to go quite as far as X, or like how, what have you found to be beneficial in terms of engagement? Because I know for a lot of relatively early stage companies, this is all resource, isn't it? It's all resource that you're trying to work out how to deploy. But at the same time, I have heard of one or two other companies as well who found it really beneficial to go much further down the value chain than their solution set might actually indicate. So what's been the story on that for you?
I would say at this point, we're still a ways from creating a coherent strategy on that, Alex, to be perfectly honest. But what I would say is that what we have found is that the amount of awareness and knowledge building that you can do at whatever stage is beneficial. And the answer is different depending on who your local partner is. For a local ready mix company like Burnco, they have a lot of personal relationships they've built within the city and the province with the city of Calgary or local home builders and people like that. And in those cases, we'll do lunch and learns together with them, right? Like we will talk to these stakeholders directly with the person who's actually ordering the concrete load to go out in a week or month's time. In other cases, with multinational integrated companies like Cemex and CRH, it tends to be at a much higher level because they already have that ground game figured out. So I think it's very much a case by case thing. But ultimately, what I would say is what we've done in the 3 years that we've really started to promote our product and had production go out into commercial projects, we've very much tried to increase just awareness as much as we can with public forums and conferences, and ultimately tried to have these conversations where we dive into case studies, right? Like, so if you're a home builder, you really don't care about what we've done for sidewalks. You want to care about the 400 or 500 home foundations that we've done and how those projects have been and how those trends have evolved and things like that. So we're trying as much as possible to build these portfolio of case studies, and I think we'll have a much more sophisticated way of tackling this in the next year or two, and frankly, hopefully, would see the rest of the ecosystem develop a much more sophisticated way of managing this very complex supply chain as well.
Okay, well, let me draw this then to a close with two very linked questions, I think. So part one of the question is, in fact, we're addressing this and you're coming to our event that's looking at it, Decarb Tech Invest in Boston. But there is this sense that as companies with excellent technology, excellent use cases, excellent demand pools are getting through each stage of growth in the kind of industrial decarb sphere, it's challenging. So I guess part one is, what do you think, if you had to really look at the work you've done as a team to get through those different levels of scale, both scale of funding rounds, but also scale of tech, what's been the secret sauce? What's got you through that others can maybe mull on, think about in their own journey? And then the second is, so moving forward from there, what's your expectation of what the next couple of years has in store for you?
Yeah, I'll be very brief on the first part of that, Alex. I think the biggest piece of advice I'd have to anybody, looking to enter the space or just having entered the space recently would be capital efficiency. It is a very, very capital intensive sector generally. Carbon to value, industrial decarbonization needs millions and millions of dollars, even at the early stage, and they quite rapidly become billions as you start, scaling up the technology to full scale industrial deployment. Having said that, that is no excuse to be, flippant about how to spend that money. I think the more capital efficient you can be till you get to the growth stage, the better primed you are for success. And I think being able to do that through leveraging, any types of incentives that might be out there, whether they are government grants or, family offices or any type of other support that you can get, I would say is massively critical and something that should not be underestimated, regardless of how strong your investor base may ultimately turn out to be, because they will give you credit for that over time. In terms of what the next couple of years hold for us, Alex, I think a lot of it is around strengthening that connective tissue piece that you talked about earlier. We've started making some really strong relationships in the cement sector for sure, but also in mining and steel and with the income and power generation sector as well. And I think to what you asked about in your previous question about engaging the supply chain, I think there's a huge amount of work that we need to do on that front as well. And so over the next 12 to 14 months, we're going to have 3 different plants going online on top of the units that we already have running in Canada, in Western Canada. And so having those go up and running would be a massive milestone for us to show that we can take different feedstocks in different regions and make cementitious product that can lower the clinker factor or the carbon emissions of the local building materials industry, and coupling that with the type of project deployment chops that we want to build in-house. We want to be the company that has a team of master builders that go out and deliver these projects at 5, 10, 50x bigger than what we've got now over the next 10 to 15 years. So we're taking a very long view to this. And our view is that all of the experience that we're going to have as we deploy these projects over the next couple of years is going to really stay kind of pull the foundation together for the scale of work that has to happen after. So very excited about all of the growth that's going to come with it. But most importantly, we're going to be tracking the amount of tons we sequester and abate every week, every month. And we want that number to be, not in the few hundreds of tons as it is now, but in the few thousands and hundreds of thousands of tons in a couple of years' time as these plants go up and running.
Yeah, I can just imagine that within a team that's worked so hard to innovate, scale that innovation, commercialize that, actually something as simple as that ticker ever moving upwards must be or would be incredibly motivating. So congratulations on all you've achieved so far, Apoorv. I think it's incredible. I'm so pleased that you were able to join the podcast today. Thank you so much.
Thanks so much, Alex.
At Jano Media, we recognise that great content has the power to create impactful and positive change for lives and society. Whether that's video, live streams, photography or podcasts, partnering with us will enable you to harness the power of content to engage, inform and inspire. Reach out to us today.